Children, today is my sixth lecture on rate of reaction in chemical equation. Now listen, previous class we have discussed the combination reaction. In combination reaction we have already discussed the burning of coal, burning of natural gases. These two topics we have covered it. Third, decomposition of vegetables and respiration or digestion. This all types of reaction comes under the exothermic reactions. Exothermic reactions are those reactions in which heat energy is given out. Now, mainly I need to explain this. The respiration and digestion. Children, whatever the food we are taking, say, you take the food as a potato, wheat, bread, whatsoever may be the food you are taking. You are taking the carbohydrates. The carbohydrate is broken down into the glucose and fructose. This glucose again undergoes oxidation. The oxygen present in your cell and gives you the energy, gets converted into the energy. Now how the reaction is taking place, that also I am telling you, that glucose C6H12O6 plus O2 gives what it will give you? CO2 plus H2O and plus energy. Now can you can balance it out? This reaction can be balanced. Carbon is 6. You have got one carbon, so multiply it by 6. Now how many oxygen you have? Carbon 6. How many hydrogen? Check it. 12 hydrogen, you have got 2 hydrogen. So you can ask it for 6 H2O. Now 12 hydrogen, 6 to the 12 hydrogen and 6 carbon. Now check it the oxygen. Oxygen you have got 6 and plus 2, 8. Now how many oxygen you have? 6 and 12. Now how many oxygen you need to correct it? Plus 6 to the 12 and 6, 18. You have 6. Now you need 12 more. So 6 O2. Now it is your balanced. This is the respiration, the chemical reaction taking place during the respiration and digestion of food. We are getting the energy. It is also comes under the category of exothermic reaction. Now, we will tell you another topic is the next type of reaction is a decomposition reaction. Let me explain the decomposition reaction, what happens into that. Now I have already written, just see, it will be easier for us. Decomposition reaction. Decomposition term itself signifies the chemical reaction in which a single reactant can decompose into 2 or more products. The reactant in the combination reaction, 2 or more reactants combine to form a single product. Here the reactant decomposes into 2 or more products and byproducts. For example, you can take it any, for example, see here first example I am taking during that is decomposition reaction, is a thermal decomposition reaction. What do you mean by the term thermal decomposition? The decomposition reaction takes place in presence of heat is known as thermal decomposition reaction. Means by heating a reaction, the reactant undergoes decomposition. Here, what happens? You are taking FeSO4, take it to the crystalline form also. See, FeSO4, 7H2O, it is a sulfur iron sulfate crystal. When you are heating it, you will get it. When you heat it, you are getting FeSO4 plus 7H2O. it loses the water crystallization, and thereafter, further if you continue to hit FeSO4, then FeSO4, Fe2O3 plus SO2 plus SO3, and you will get the sulfur dioxide smoke while heating it. Initially, when you will heat it, it will lose the water of crystallization, and the color of the crystal, that is the green color of the crystal, will get converted into the white color, and then if this further you are heating it, it will give you the Fe2O3, SO2 and SO3 sulfur dioxide fumes will be clearly visible to you. I am going to explain you this by using the by heating the FeSO4 7H2O. Just see. Children, I am taking a test tube in which I am putting the FeSO4 7H2O. Now let me light the इधर दिखाइए आप. Let me heat it the our mixer. Now see, the gas is coming out from this. This is the sulfur dioxide gas. The color has changed now, it become the white. Color is changed and it become the white. A gas is coming out. You can see this is the sulfur dioxide gas. It is clearly, the smoke is visible. Initially it has lost the water of crystallization and become white, and further we have continuously heating and it is giving you the sulfur dioxide gas. Okay. Okay. So I have explained you the topic heating of thermal decomposition of FeSO4. Now second I am telling you the second topic, that is what happens when calcium carbonate is heated. When you heat the calcium carbonate, it is also a thermal decomposition reaction in which limestone gets converted to the lime and carbon dioxide. Limestone, CaCO3 is your limestone, and you are getting the lime. Under this reaction I can show you by using the activity. You can heat it and taking the limestone again. You can prepare just limestone just to do this. Let me explain it. It is a calcium carbonate. Now it is a calcium carbonate. We are going for the thermal decomposition reaction for this. See, the mainly calcium carbonate requires the strong heating. It is a strongly heating of the calcium carbonate, then only it gives you the lime, and then it is clearly visible. You can see that how it is getting the water of crystallization is lost. It is also coming inside that. It is losing the water, but it is taking more time. See, by heating that you will get the carbon dioxide. It takes time. So let me explain the topic. It is going much in that. You have heated limestone and you are getting the lime and carbon dioxide. Carbon dioxide you can test it by putting the matchstick on the mouth of the test tube. The carbon dioxide will prove that the matchstick will put out. Now the children, the third topic, it is also the thermal decomposition. It is thermal by heating the lead nitrate. When you are heating the lead nitrate heating, you are getting that is a white colored lead nitrate. Upon heating gets converted into the lead oxide that is yellow in color and NO2 brown color and remember it. It is also a thermal decomposition reaction because the reaction takes place in presence of heat. One point I wanted to tell you that we have not discussed, which is already covered in the combination reaction. In the combination reaction, one of the reaction was there, question was there, why quicklime is used in whitewashing. At the same time, why the wall shine after whitewashing? Why the wall shine? The answer of why the wall shine. Remember it. What are the total chemical process occurs in that? I am explaining you. Initially, CaCO3 equals CaO plus CO2. It is a quicklime, limestone, quicklime. And then quicklime is getting converted into the slag lime by reaction with the water, CaOH2. Now, the slag lime, CaOH2. This CaOH2 you are applying on the wall. The calcium hydroxide, when you apply on the wall, after 2 to 3 days, it reacts with atmospheric carbon dioxide and again it will form you the calcium carbonate. The calcium carbonate has got the shining property. That's why the wall shine. CaCO3 plus H2O. Now check it, is it balanced or not? 2 plus CaCO3, CO2, CaCO3 plus H2O. Now you have got 2 hydrogen, oxygen 4, 2 and 2, 4. So we can go ahead with that oxygen 2 to 4, oxygen 3, 1, 4, it is balanced. It is balanced. Now, here, check it, due to this formation, white in color, that's why the one sign. So this is the answer for that. Now check it whether all the reaction is balanced or not. We have taught you the thermal decomposition of FeSO4, FeSO4, 7H2, FeSO4. Now Fe2O3, SO2 plus SO3, it is balanced. CaCO3, SaO, CO2, it is balanced. Lead nitrate. PbNO3, how many PbNO3? See, take it 2 PbNO3. Now how many nitrogen you have? 2 to the 4, then 4 NO2. 4 NO2, then how many oxygen you have? Lead 2, then put it lead 2, then how many oxygen you have? 4 to the 8, here 3 to the 6 to the 12. Now you have got 4 to the 8 to 10 and to 12, which is balanced. Complete balance. So, the children, I am concluding my lecture up to the thermal decomposition reaction, and we will be in the coming class, we will be coming with you with lot many activity related to the, one of the major activity is the electrolysis. It is also the decomposition reaction. We will teach you the decomposition in presence of sunlight. There are the two topics left. Thank you.